Good afternoon. This topic is a very complicated topic, as all of you know. And the short time I have, I'll concentrate mostly on technology-related issues. And again, I'd like to thank Congressman Ryan and Congressman Reed for the invitation to speak today. I guess the first thing we all ought to know is that the United States is indeed the strongest nation in many fields of manufacturing. When you're overseas, you realize the power of this country. And I think we have done well to innovate many new technologies. And indeed, many of our companies are models other countries and other companies and other nations are trying to emulate. Manufacturing is an important and also very complicated field. When you talk to economists, they have different views than the views we have as engineers and technologists. And if you talk to people in industry, they have one kind of view, and people in academia are pursuing different things. So it's a very diverse and complicated subject, and I'll mostly address technology-related issues. I'm not a businessman. I haven't run a factory myself, so I tend to be more academic. But I've been involved in manufacturing for a long time. In some ways, it began as an accident of my life. I got into manufacturing because I needed a job after finishing my junior year at MIT, and I desperately needed income. And it happened that a small company behind MIT was looking for an engineer. So I applied and I got the job. Turned out I was the only engineer they had. Other people were foremen, machinists, and so forth. And there, it turned out that I ended up creating a plastic composite product that made billions of cups and whatnot since then. And machine that makes the cup, this composite laminates, and then the manufacturing system that produce these things in large quantities. These machines are still running, and sometimes you might have used it. It's sold by the name of Sweetheart Plastics. So sometimes when you see Sweetheart Plastics, it's the company I was with. And then I joined other companies, and I did similar things. So that's how I got hands-on experience in actually creating manufacturing systems, products, and for whatever reason, I ended up continuing doing that. And at MIT, as a result of this kind of practical work I did, I created a theory called XMA design theory, which has been used to create other complicated systems. So just to give you a background of things that I did, I worked with many companies in many of these areas. At one point, we ran a consortium-sponsored research program at MIT. And one of the things that we did at MIT was create a laboratory for manufacturing productivity, because in the early 1970s, MIT was concerned about the U.S. competitiveness. So MIT decided to create an organization, and then I happened to be involved with that creation of lab for manufacturing productivity. Since then, this lab has done many different things. And so I'll elaborate more on this. And then also when I was at NSF, I was the one who actually oversaw the creation of ERC program, and ERC still is running after all these years. And there we try to emphasize research in manufacturing as well, with the support at the university, with the support of industrial firms. So that's still going on here in the US. So all these different things that I was involved with gave me a certain perspective on what we need to do. We hear a lot of discussion about jobs going overseas and so forth. And I'll just give you an example that's not confined to the United States. In 1980, I was involved with Korea's economic development as a World Bank consultant. At the time, Korea invested a lot of money in 70s in heavy industries. and they were having a hard time making it go over all this investment. In one of those industries was shipbuilding. And since then, Korea has done very well for 30 years or so. But now Korea is losing that business to China. Because of high labor costs, Korea is no longer competitive in shipbuilding, so it's going to China. And so every country faces this problem as the economy develops, their wage goes up, then that they have to deal with some of these issues. Universities, I think, play a major role in manufacturing, should play a major role in manufacturing, perhaps a lot more than we are doing today. First of all, the universities create people who can become future leaders. And without universities creating these leaders, then you cannot really foresee too many good things happening in industry. So I think universities in the United States have done a very good job. Can you imagine that all top 20 universities are mostly U.S. universities? And the universities in other countries are trying to follow the footsteps of American universities. So U.S. universities, American universities have done a great job of creating knowledge and people, and that still should continue to do so. And then U.S. universities also create a lot of technology, as many of you know. Because of time, I'll just move on to some of the four items that MIT had something to do in creating technology. First thing is NC machine tools. Today, you cannot think of going into manufacturing without NC machine tools. And 3D printing, you hear a lot about 3D printing. And also MIT made a major contribution there. So in the case of NC machine tools, it's not MIT's invention. The invention was made by John Parsons of Michigan. And he won the national medal during the Reagan presidency. And he's the one who had this idea that you can make a very complicated part by being able to 3 axes so that you can machine complicated shapes. And MIT was given the money by the U.S. Air Force to develop the concept into a machine. So MIT Servo Mechanisms Lab created NC machine tools. And that in turn created computer-aided design, all these other technologies. And today, you cannot think of manufacturing without NC machine tools. But it required universities like MIT to create this. 3D printing is a new technology that essentially lays, when you try to make complicated three-dimensional parts, instead of trying to make it all at once, it's really by layer, two-dimensional layer, you build up and create three-dimensional structures. And it shows a lot of promise, and was done by, at the time, young professor at MIT, Ellie Sachs, and now it's becoming a very important technology used worldwide. You cannot think of making complicated power without using 3D printing. Another thing that we did was create a plastic that has tiny little bubbles in it, bubbles that are about 10 microns in size and billions per cubic centimeter. And this kind of plastic uses less material, you can produce much faster, and so on and so forth. Now it's used in automotives and other areas. And in fact, I claim that every injection molded plastic part should be made this way because it's cheaper, better, dimensionally more accurate, and faster to produce and so forth. And finally, through the very theoretical work on XML design, we have created a lot of different things. The latest thing we created was what I call online electric vehicle, or OLEV. This is an electric vehicle that gets its electric power from underground cable wirelessly. So we don't have to have batteries. Although all these buses have one battery, so they can go on the road, still be able to move around the road without underground power supply system. It's running in Korea. And the important point is the theory enabled us to develop all these complicated things in 2 years. From the date we started the project and until we installed the system, took 2 to 3 years. Not 10 years, 13 years. People think these things should take. And so theory is very important because it illuminates the need to do that. In industry, many people think that Six Sigma is the way to go, and certainly is a very good thing to do. But it turns out that in spite of using Six Sigma, if you do not violate some of these basic theories, then what happens, you have the situation we had with the ignition switch. Sometimes it fails. Few fails, and a lot of people get killed, and so on and so forth. So I'll try to wrap it up. And I have a few thoughts about what the future of manufacturing should be like. But in view of time, I'll forgo that and then perhaps answer any questions if you have any. Thank you.